Okay, everybody, here we are back in the lab. We have a new project. We're using the Arduino Mega 2560 R3 board made by ELEGOO. This runs the ATmega 2560 processor. And so we're going to use this board to implement a project for remote controlling a 2-axis light, a searchlight that I'll put at my second home. When I'm not there, I can use this light to pan the light up and down, left and right, and view through the cameras what may be happening outside the home. We're going to use an Ethernet hat. It's compatible with the Mega R3 board, and we're going to use this to connect to the network so that we can remotely come into this board and control the light. The light is going to be controlled through these relays. This is an 8-module relay board that I use with Arduino and Raspberry Pis. It's a very good relay module. It's opto-isolated. These opto-isolators totally isolate the drive side from the load side. Really high quality relay board, so we're going to use this one today. So let's get started. We're going to use some jumpers that I have to jumper this together. When we finally construct the final assembly, we'll use permanent wiring or mount it in an enclosure, but we're going to go ahead and set it up now and get prepared to start developing the Arduino firmware. These are just simple jumpers that have male ends and female ends. Let's take a look at the schematic right now on the Arduino board and at the connector that we're going to use to connect up the various digital I/O and to grab power off the Arduino board. We will be using the XIO connector for digital I/O on the Arduino board. We will obtain 5 volts from pin 1 and 2 and ground from 35 and 36. We're going to use 24 to 32, at least we're going to start out with those pins for digital I/O. That will provide the 5 signals to the relay board to control the relays. That will be PC5 rather, to PA2. We will put those pins in digital output mode. Okay, let's connect it up. The Ethernet shield or hat just simply sockets right up to the Arduino. So let's get that done. So just snap right in. Make sure you check your clearances. You want to make sure there's nothing touching this shield on the serial connector. The connectors kind of get very close if you see here. So you want to make sure it's uniform and not touching or shorting. Okay, that's it. Let's get the power going. I have some test leads here that I can quickly just connect into. The plus and the negative here. Just a quick test here. This is nothing permanent, so don't let the frayed wires upset you too much. We're just going to get our power here for this to get the board powered up for programming it and doing what we need to do. That one's giving me a little trouble. Should be able to just get that in there and going really quickly. Okay, that should do it. Just make sure those are not shorting. Connect up the serial. The serial's powering the board up. Now, I have powered USB, so you'll notice the board's powering up. So that's okay. We're going to go ahead and provide supplemental power in a moment. So I'm going to keep this unconnected right now so the board's not powered while I make the rest of my connections. We'll then provide, the main current through these connections right here. This is a little bit, these connections are a little bit squirrely, so I'm going to clean these up right quick. Should be able to just slide right into these connectors. These are flat blade connectors, and all I'm doing is just sliding the wires in there so that we can just get some contact for providing the extra power. I may have to strip that one back a little more. Yeah, that should do it. Okay, let's connect up the I/O and the 5-volt supply to the relay board. The relay board needs 5 volts. So it gets 5 volts here and ground on this connector. Now, ground is down on the 2 bottom connectors of this particular connector that we looked at a moment ago. So we're going to grab our ground here, and we're going to ground our plus 5 volts up here. Now, this relay board separates the logic side 5 volts from the relay side coil voltage on the other side of the opto isolators here. So that's what this connector is for here. So we have to supply that from 5 volts. Now, if you want total isolation, you would use a separate 5 volt supply. You wouldn't share the 5 volt supply. But opto isolation is not a real problem here. So we're just going to grab our 5 volts. Okay, so now we have 5 relays we're going to use. One is for power, one is for left, right, up, and down. So we're going to use relays 1, 2, 3, 4, 5. We will not use the remaining 3 to control the light's power, and then the up, down, left, and right controls. So we're going to start that by getting port 24 right here. And we're going to start, and we're going to drive relay 1 with that. And then the next port 26. '28. 30. And 32. There we go. So let's double check. So to make sure, double check your schematic and your connector and make sure you have 5 volts on the 5 volts pin and ground on the ground pin. Make sure your I/O pins are properly connected. We're using 24 to 32. We have supplemental power. We have Ethernet in place. And so what we're going to do is we're going to power this board up, make sure it comes up. There will be no firmware running on our Arduino, and then we're going to go write a quick test program and power it up. The test program will just turn the relays on and off, on and off, on and off, and that'll kind of verify all the connectivity and control to the relays is in place. Okay, so I wanted to show you right quick the test software that we put together, or the test firmware for the Arduino to test the relays that you just saw. So it's a really simple program. In the setup loop, or the setup function, you'll see here, we simply just put the pins in output mode. Here are the pins. They correspond to the connector 24, 26, 28, 30, and 32. And so we simply initialize the pins by putting those pins in output mode. And in the main loop, we turn the pins off, and then we delay, and we turn the pins on, and we delay, and then the loop loops back around, and it continues and continues forever. Now in this case, active for our relay is low. So putting a high potential, or 5 volts, on the pin actually turns the relay off. When we put a low on the digital pin, it actually turns the relay on. So that's why it's opposite. High is actually off, and low is actually on for the relays, the particular relay module that we're using. Okay, so we're ready with the test program. The test program is very simple. It's going to turn all the LEDs on, delay a second, turn them off, delay a second, turn them on forever until we stop it. So we're going to make sure all 5 LEDs are turning on and off. I'm not powering the relay section. We'll do that to check and make sure the relay is energized, which checks the relay module to make sure the output of the opto isolators is actually driving and turning the relays on and off. So let's give it a shot. I'm going to load the software right now. Okay, so here we are. First mistake was on the block of code that turns them on, I actually did not toggle the state. Second mistake was I did a delay 1, which is a millisecond delay, so they came on and stayed on because it was switching so fast. They just appeared to be on all the time. So I got the delay right, and you can see now they are toggling every second. So we have relay 1, 2, 3, 4, 5. I hope you can see those. Let's make sure the wires are out of the way. So you can see the LEDs toggling. All right, let's power up the relay side, and the relay should start activating. You'll hear them if you listen carefully. So I hope you can hear that clicking on and off. That's the 5 relays clicking on and off. So we're good to go. We have verified that IO control 24 to 32 is actually energizing the relay, and the test program is running. The next step will be to work on the Arduino firmware, which will receive commands from a remote client and actually actuate the relays so that the light can be turned on and then activated left, right, up, and down. So you can see here, this is actually a live internet. You can see there's some actual activity going on here currently. So there is connectivity to the Ethernet cable. There's no Ethernet program running on this firmware that's been loaded. So the next time we'll talk about how to set up a server, a TCP server to receive commands over the internet, and those commands will allow us to control the remote control light.